to accommodate all this issue I previously shared, I think that's important to use the technology levers that are available today. First point is to leverage the nuclear knowledge that has been accumulated for large NPP, Gen 3, and all the R&D activity. Second point is we need to leverage the system modeling and the system of system modeling. And third pillar is to have a full data-centric approach at the beginning of the project to make sure that we will be able to accelerate the licensing phase and the design phase. And if I move to the next slide, this is a methodology that is very common for other industrial domain, but it's not very used today in nuclear, unfortunately. But this is something that is very important, is to use model-based system engineering methodology to define a digital twin of the project and to leverage collaboration, traceability at any stage of the project. On this slide, you can see that there is a twofold integration. First, for each phase, we are running with we are modeling the organizational breakdown structures, then the work package, functional, and the product breakdown structures. So we start with the conceptual design, and then we propagate this modeling activity to engineering, procurement, manufacturing, construction, commissioning, exploitation, etc. All the project is described under diagrams, and that will serve as an ontology or ontologies to feed with all the data related to the project. That's very important to do that. This is done in the field of aeronautic and space and defense for many years, but not for nuclear. So now if it comes to the digital ecosystem that we have to set up, and again, our recommendation is to set up this digital ecosystem at the very beginning of the project, because otherwise you start creating data and you don't know how the data will be stored, how the data will be manipulated, exchanged, etc., etc. Doing that at the very beginning of the project, you have the full landscape, you have all the software that will have to be coupled and connected. And this is an example where, of course, you start with the modeling, MBSE, and then you host the engineering data inside the PLM. Then you have a natural coupling with the building information modeling platform. Then you have another coupling between the project management platform. That's very important. Once you have this scheme, you need to have the full common data environment for this ecosystem. The proposal is you need to define CDE masters and to have a CDE slaves. And for instance, all the engineering will host the CDE masters, and then you will have a CDE slaves for the BIM and for the PMIS. So this is for the design, construction, commissioning. Then you move to operation and maintenance. You will need to still have the BIM data, the engineering data, and you will see arriving the CMMS platform, because you need to make sure that the maintenance regime will be very well handled, and you have to do the asset management. This I can skip, and I will now move to some concrete digital enablers after the methodology part. The first point is the safety. So the safety is essential for this type of project because first, the TRL are not very stable. There are some project TRL3, other TRL5, 6, etc. And the interaction with the national safety authority sometimes are rather complex. So what we are proposing here is to have an integrative framework where all the safety activity will be integrated. So you have on one side the requirements, and then we are proposing to do a requirements breakdown structure using the methodology I previously described. Then in the middle you have the system modeling with of course the functional breakdown structures, the logical breakdown structure, and you can also model some dynamic functional analysis, because sometimes you need to have some dynamic functional analysis, especially when you will have some passive safety system. On the right side, you are coupling the physical modeling. The physical modeling can be hosted on a particular software, but also it can be done on a system modeling software like OpenModelica, etc. And you are connecting the both. And there is one thing which is very important, is to use the formal language to verify that the requirements will be covered. So what we are using today is we are using the Common Requirements Modeling Language, CRML, which is a formal language, to make sure that the requirements, to prove that the requirements are effectively covered by the system modeling and the physical modeling. So that's very important. The CRML, for those that are not familiar, this is a language that transcripts the requirements into Boolean algebra, and that creates a formal. So doing that, we propose a new approach to accelerate the licensing phase. I can skip that. And I just want to give you some concrete example of how our methodology has been implemented on the molten salt reactors, and this is an area startup. So on this slide, we first develop all the modeling part, and then using the PLM, we have the safety requirement structures fully connected with the system requirement structures. And of course, that ensures a seamless safety data. That means that all the data are connected. When we are modifying something, we see immediately the impacted system, and that's very important. And of course, this generic method is constituting a sort of library where you can duplicate for other projects. And for other projects, let's say you have one project in UK, and you have to move to another country where the safety standards will be a little bit different. So you can duplicate all the data, compare with the new requirement system, identifies the delta, and then concentrate only on the delta. So that's very important. This is a full scheme that has been implemented using it was using Katia Magic modules for from the 3D experience, and then the PLM. So here you have the full traceability and the conformity for the different safety function. So you have in red the coverage of needs by requirements and the link. So you have, as I said before, safety requirement, system requirement, and then you have a propagation concerning the subsystem and then the function. The next use case that accelerates the licensing phase, this is how to automatize and how to change the physical simulation. So here we are starting some simulation outside the platform. We are exporting the mesh, and then we are coupling the mesh in a different software, and then we are reintegrating the result into the 3D experience platform. That's important because using this way, you don't need to export files and to get some risk of having data corrupted, etc., etc. And of course that accelerates the neutron calculation because you are not doing the meshing activity 2 times. I think, okay. So that's another things that we have recently developed. It's a sort of a PLM Analytics powered by large language models. So here we are reading the documents using a large language model that has been developed by us and using our dataset to train the models. And you will see that we are creating automatically the PBS. You will see on a screen the PBS is automatically created, and then the system architect, they only have to verify that the models is correctly described. That again, that accelerates the way the design will be done. We have done that. If I move to the requirements, same thing, and you are reading the documents, and from the documents we are using the large language model to create the models, and these models are incorporated into the CATIA Magic modules I have shown before, and then connected to the PLM platform. That automatize all the tasks, concentrate only the requirement engineers to verify that the model are very well are well assessed and they can modify it. And again, this can be very useful when you will have to duplicate the project. And so this is you have the different building blocks, and then you will see at the end the creation of the model with the hierarchy between the different blocks. And so you can see the display, all parts, you will see the hierarchy. It's a little bit slow, and so you have here the RBS model automatically created, and of course the requirements engineers, they can enter into the different diagrams, modify the link, or because they estimate that the machine did something wrong. Some key takeaway before taking some question. The Gen 4 reactors will be massive manufactures and installed. That means we need to use the digital technology to make sure that we will move to a traditional first of a kind project like we have for large nuclear power plant, to a sort of products manufacturing series. And you have seen that all I have presented are building blocks of having a digital twin of the product, but also of the project, because we will incorporate the organization. That will be very important. And this is very essential if we want to disrupt the lead time. Very important message. Comprehensive digital ecosystem has to be set up at the very beginning of the project. Data-centric approach are mandatory, system modeling also mandatory, because that will ensure collaboration between teams located in a different place, having the perfect mastery of the configuration of the product. And once you have that, of course, it will be easier to use artificial intelligence like large language model or hyper automation technology to again or further accelerate the delivery of the project. So this is more or less, but I can't now turn my camera. Question. Do you hear me?
Yes.
Okay, so that was some sharing from our system and from our background in the field of advanced modular reactors. To support this project, we have created a specific department dedicated to supporting the project owners for this new technology.
Okay. Thank you, Robert, for presentation. We still have a few minutes till the next session. Do we have any questions or comments for Dr. Plana? Yes, Duane, go ahead, please.
On that microphone button. Dr. Plana, thank you for that excellent presentation. First, I'll make a comment. That looks like ITER components behind you on the screen. Is that what we're looking at?
This is this is a tokamak.
Yeah, there you go, tokamak. There you go. Yeah, very nice. That would be definitely Gen 4. Your product looks amazing. Are there heavy platform requirements, or will it run on a desktop? Does it require a larger computing system, or can it be used from a single laptop?
That's very interesting, because thanks for this question. For the project I mentioned, it has been decided to use cloud architectures. And that's very interesting, because using cloud architectures, you can use the flexibility of the clouds. If you need to have more virtual machine, you can order virtual machine. If you need less, you can use less. So that's part of the question. Part of my answer is today we are suggesting to use cloud, and it can be sovereign clouds in a different country. And for instance, in UK, recently Oracle Cloud has been certified by the Minister of Defense. So you have one cloud for the defense activity, which is a private cloud for the Ministry of Defense. Today, if you decide to move on premise, you need to for the artificial intelligence, the large language model. This is where you need more computation time, and then you need computer with 4 GPU core to run the model. because the model we are using, this is a 40 billion parameter model. Is not as big as a GPT model, which is 165 billion. So we are using a much less one. I would also mention that if you have your nuclear dataset with appropriate ontology, datasets, etc., you can reduce the number of parameters that might be needed for configuring the large language model. And this is something that we start to see arriving. There is a lot of research where people try to use supervised data sets to make sure that the large language model could be shrink to a small number. And we can expect to have a model with less than 10 billion of parameters in the future, and that will be run on a scientific computer, but not very big.
Very interesting. Thank you very much for your answer.
Yes, Marina.
Hello, thank you very much for interesting presentation, although I had a big problems to see that at the beginning, but in the second and third set, I have done that. I have a very short question. Do you have already some customer using this terrific artificial intelligence issues in your program? Have you already some customers and some references?
Yes, thanks for the comments and question. The large language model is starting to be used with EDF to accelerate the structuration of the requirements. That's the first point. The second point, with one startup we are working on, we will be experimenting also the use of the large language model. And because today, honestly, the technology are there. It's just a matter of having the data set available to train the model. But the LLM technology, very mature, very mature.
Okay, thanks a lot.
Thank you.
Robert, I have to use my advantage as a moderator, question you from the organizational point of view. If you were organizing a conference on SMRs in Europe, which city would be the best together, biggest number and best experts? Paris, London, or any other city? As a casual question.
Yeah. As I'm French, I would have probably the bias to say it's probably Paris. No. More seriously, if I see, I would say in France we probably have a larger advanced modular reactor program than in UK. So we have a lot of startups already selected, running. Yeah. So it might be a good seed to have a lot of attendees. UK, they have a large nuclear program. They have a couple of startups. But for instance, Nucleo, they have some subsidiary in UK, but the main headquarters are Italy and France. You have Horizon, Netherlands, subsidiary in France. There is a couple of there is a Maltex Molten Flex Energy, UK. There is a couple of startups in UK, but I would suggest that perhaps Paris will be a better location at this stage because we have a bigger nuclear program for AMR in France than in UK.
Okay. I mean, you'll be one of the first people we're going to get in touch for the organization next year.
Yeah,
and I guess
we will be happy to support you.
you are
And they
based
cannot,
yes.
they cannot make crepes in the UK like they do in Paris.
Come again?
They cannot make crepes in the UK like they do in Paris.
Yeah, of course.
Okay. So yeah, and maybe if we'll have time, you're gonna show us those courts in Roland Garros. I see that you're a big fan. So anyways, merci beaucoup, Dr. Plana. Thank you.
Okay. Thank you.